Corporate boardrooms are currently pouring billions of dollars into artificial intelligence, expecting massive productivity gains. Yet the actual enterprise value realized from these deployments remains statistically negligible. We are watching a massive technological force collide with an unyielding systemic barrier. The technology works, but the container holding it refuses to adapt. Recent data from Stanford University's Human-Centered AI Institute shows that 88% of global organizations have now adopted AI in at least one business unit. Despite an 88% adoption rate, McKinsey reveals only 1% of companies achieve AI maturity, where technology is deeply embedded to generate systemic value. The cause is structural. Companies purchase high-leverage AI tools and layer them directly over legacy, top-down decision-making hierarchies. A 78% failure rate in AI integration points directly to organizational design failure, not a technological limitation. To evaluate post-AI organizational competitiveness, we have to look at the math dictating these failures, specifically a framework developed by the Tencent Research Institute. Competitiveness equals talent density multiplied by the AI lever divided by organizational friction. Giving an employee a large language model spikes the numerator, multiplying individual capacity. However, the denominator, organizational friction, consists of cross-departmental alignment, endless approvals, and information decay across the hierarchy. Bypassing this friction requires a new type of worker, the super individual. This is a knowledge worker who has transitioned away from executing single-domain tasks and now orchestrates AI to achieve cross-functional closure entirely on their own. Take the AI programming team CodeBuddy. A single developer on their team directs AI to output 10,000 lines of code overnight. They no longer type out functions. They act as an architect, defining constraints and reviewing outputs. If you place that hyper-efficient individual numerator inside a highly bureaucratic denominator, the organizational friction eats the gains. The net organizational output remains flat. AI dramatically expands the capabilities of the individual. This leads to a popular assumption that teams will dissolve entirely, giving rise to millions of solo enterprises. The legacy knowledge worker was strictly bounded by their specialized domain and their total reliance on the organization to provide structure, tools, and distribution. This diagram illustrates the three structural constraints that limit even the most powerful AI-empowered solo operator: risk concentration, attention residue, and systemic trust. First, risk concentration. A centralized single-person decision system lacks redundancy. It is highly vulnerable to catastrophic single-point failures. Second, attention residue. When a single individual uses high-throughput AI, decision density explodes. Forcing a human to context switch across 50 macro decisions an hour guarantees severe cognitive decay. Finally, systemic trust. Enterprise clients deciding where to allocate $1 million budget require the decentralized credit and long-term reliability of a multi-node entity. They will not anchor that risk to a single point of contact. Traditional collaboration was about fitting specialized puzzle pieces together. One person writes the code, another designs the interface. The new model operates on advantage resonance. Individuals now bring their overlapping AI-amplified strengths to a shared problem space. They don't fill gaps, they multiply each other's output. Teams in the AI era do not exist to divide tasks. They exist to absorb risk, accumulate trust, and stabilize focus. Once super individuals aggregate, they must be structured. Frontier organizations are currently organizing along a specific topology. This matrix maps team structures across two axes: the presence of a central human node on the y-axis against the level of AI coordination on the x-axis. Morphology 1 is the node radiating team. In this structure, a central human makes all judgments. Surrounding nodes and AI tools are utilized strictly to rapidly scale the execution of those central decisions. The hard boundary of this model is human limitation. The entire team's output is strictly capped by the cognitive bandwidth and blind spots of that single central node. Morphology 2 is the network collaborative team. This operates as a peer-to-peer structure. Multiple super individuals execute autonomously and coordinate directly, without a central commander routing the traffic. Consider the AI startup Kimi. They operate a 300-person organization with 0 KPIs and no middle management. Their 5 founders route directly to individual contributors. When AI grants every individual full execution capabilities, middle management relay layers lose their utility. The hierarchy flattens because the structural reasons for vertical silos no longer exist. The most experimental topology removes human coordination entirely. This is Morphology 3, the AI Central Model. The lower right quadrant represents the AI Central Model. Here, the system itself coordinates the network, managing the handoffs and synchronization typically handled by human managers. In the Multikaya case study, a core team of exactly 4 humans orchestrates dozens of autonomous agents. Those agents execute millions of requests, while the humans act solely as validators. This is powered by agent-to-agent, or A-to-A communication. If a marketing agent needs technical data, it bypasses human scheduling and directly queries an engineering agent. Cross-departmental alignment friction is absorbed by the machines. Operating at this velocity requires a highly specific technological substrate. Under Jack Dorsey, Block is actively pivoting its legacy infrastructure to enable this exact model, allowing direct problem ownership across a massive organization. This architecture stack outlines the required layers. The foundational layer is visibility. AI cannot coordinate if it lacks total organizational context. It requires immediate, unobstructed access to the entire company's codebase, decision logs, and documentation. The middle layer is callability. The AI must be able to actively trigger the organization's capabilities, accessing internal servers and pushing code into production. The top layer is automation. The system must proactively route tasks, synthesize information, and maintain alignment without waiting for human prompts. An organization becomes AI central when the system programmatically eliminates the information relay function of middle management, leaving humans exclusively for high-level judgment. This technological infrastructure creates an immediate human management crisis. Standardized performance indicators were designed for a time when individual output was relatively consistent. Today, that predictable consistency has completely vanished. This scatter plot compares a tightly clustered traditional performance curve against the extreme variance of an AI-enabled team. The output gap between peers now stretches from 10 to 100 times. Standardized compensation bands cannot anchor to this reality. Under CEO Dario Amodei, Anthropic abandoned traditional task tracking and strict role division. They use a unified title, member of technical staff, eliminating the split between researcher and engineer. Leadership in this environment cannot focus on assigning tasks. Management must pivot entirely to maintaining a high density of talent and enforcing rigorous cultural standards. Performance evaluation is now a systemic threat. If a 10x producer is constrained by a 1x reward structure, they will immediately exit the network to build their own. The new imperative for organizational leaders is context engineering. Context engineering requires building transparent data environments and hard rules. It is the exact opposite of directing daily traffic. You stop managing the chaos of individual outputs, and you build the infrastructure that allows for self-organizing clarity. We can now return to the Tencent Research Institute formula to see the mathematical end state of this shift. Looking back at the equation, when an organization implements super team topologies, the denominator, organizational friction, shrinks to 0. The resulting competitiveness metric scales exponentially. You cannot plan an AI-native organization from the top down. The goal of AI transformation is not to design a better hierarchy. The goal is to build an infrastructure of total transparency, establish rigorous context, and get the bureaucracy entirely out of the way.